All right, welcome back. This is Coach Dorff, and we're working on section 3.9 on related rate problems that you did for homework from the textbook. And now we're going to look at problem number 27. The problem says a water trough is 10 meters long and a cross section has the shape of an isosceles trapezoid that is 30 centimeters wide at the bottom, 80 centimeters wide at the top, and has a height of 50 centimeters. If the trough is being filled with water at a rate of 0.2 cubic meters per minute, how fast is the water level rising when the water is 30 centimeters deep? Now, this is a tough problem. Two things we need to do is, first of all, we're going to make a diagram of this so it's easier to see. And also, I'm going to change all my units so they're in the same form. So we have centimeters and we have meters in this problem. I'm going to change everything to meters. First, let's look at this diagram here. The side of it looks like a trapezoid. We're told that this length here is 10 meters, and the front part is a trapezoid. And what do we know about this trapezoid? The base of the trapezoid is 30 centimeters. I'm going to change that to meters, like I said, so that's 0.3 meters. If I now draw these kind of straight up here, it will help me determine the distances and lengths. At the top here, I've got 0.3 meters from going, if I just went straight up like that. Those are straight lines there. So the total top, though, is 80 centimeters, which is 0.8 meters. And since it's isosceles, they have to be the same amount on both sides. So this one is going to be 0.25 meters, and this is going to be 0.25 meters. The height is 50 centimeters. So that's going to be 0.5 meters here. And this is going to get filled with water. And so that water is going to have a certain height. And that will be important to let that be there because we're trying to figure out how fast is the water level rising. So we want to find the HDT. It's also going to be important or helpful to use this variable here. We'll call this A, and that's that distance right there. So let me redraw this trapezoid so it's easier to see the numbers. This height here is H. This length here is A. I know that this is 0.25. This whole length here is 0.5. And this length here is 0.3. The water is being filled. That means the volume is increasing. What's the volume of the trough? Or you can call it a box if you want to. What does it equal? Well, it's going to be the area of the trapezoid part that's being filled with water times the length, which is 10 meters. So it gives me a chance to use blue here. If that's the water there, it's going to be the area of this blue part, and let me use a different color now. We use red. It's going to be the area of that trapezoid times this length of 10. So what I need to know here is on this initial diagram here is I need to know what that area is. And so the volume of the trough is going to be the area of the trapezoid that we have down there times 10 meters that it's long. What is the area of this trapezoid? Well, generally, the area of a trapezoid is 1/2 times the sum of the bases, b1 plus b2. Then times its height. What do we have in this problem? We know that B1 is 0.3, B2 is going to be 0.3 plus 2 times A. Remember, we've got this and this. So this part here is 0.3 and this part is A. So the top of that trapezoid is going to be 0.3 plus 2A. And H is unknown, except that it's unknown right at this point because it keeps increasing and decreasing. The area of the trapezoid is then going to equal 1/2 B1, which is 0.3, plus B2, which is 0.3 plus 2A times height, or 1/2 going to be 0.6 plus 2A times H. Now, we want to get a connection between A and H so that we can get rid of one of the variables. I want to keep H because I'm looking for finding the change of the height. So since we want to find dH dt, the variable a, if we can find an equation connecting them, connecting a and h. Well, what is that equation? So we're going to use similar triangles. This is h, this is a, this whole thing here is 0.5, and this height here is 0.25. So I've got my two similar triangles. There's my clock going off again. So I've got 0.5, 0.25 on the larger triangle, and in the smaller triangle inside, I've got an h and an a. So I can use then the relationship that h over a, the height over the top, is equal to, on the smaller one, is equal to the height over the top part of the larger triangle. I can work with this and solving, I want to solve for a, if I multiply the left here by 4 over 4, I get h over a equals 2 over 1, or that tells me that a equals 1/2 h. But I need to keep h in there because in solving this problem, I'm trying to find the h dt. So going back to where we were up here, the area of the trapezoid is 1/2 0.6 plus 2 times a, but a we see from here is 1/2 h all times h. And so we then get 1/2 0.6 plus a times h, or I can then write this as 0.3 h plus 1/2 h squared. The volume was the area of the trapezoid times its length. And so using the formula we have here, we now have 0.3 h plus 1/2 h squared times its length, which was 10 meters. And so now I end up with 3h plus 5h squared, and that's the volume. Now I can take the derivative, take d dt of both sides, and so I get d dt of v equals d dt of 3h plus 5h squared. That gives me dv dt equals 3 dh dt plus 10h dh dt, which I can write as 3 plus 10h dh dt. Now we're given that, let's see, we're given that dv dt equals 0.2. Going back here, all right, where does that come from? That says down here, if the trough is being filled at the water at a rate of 0.2 cubic meters per minute. That's where we get this from. And we say, how fast is the height of the water increasing when the water is 3 centimeters deep, 30 centimeters deep? So that means h is 30 centimeters, which we're going to change to meters, which is 0.3 meters. Now we have those two. Now we're going to substitute those into the equation. So again, we have dv equals plus 10h dh dt. We're trying to solve for dh dt, so I'm going to write dh dt by itself. That's going to be 1 over 3 10a dv dt. So substituting those values in, I get 3 plus 10 times 0.3, so 8 times 0.2. And then working that out, I get 0.2 over 3 plus 3, which turns out to be the same as 1 over 30. And then what are my units? I have the volume here was cubic meters per minute, I believe. What do I have on the bottom? The h, which is meters here, and so meters squared per minute, but that's not right. It should be just meters per minute. Thanks.